Afternoon. We are still on differential calculus. We are on subtopic 3, which is gradient function. Gradient function is one of subtopic under differential calculus. Recall under the coordinates, under the gradient is gradient. We normally represent as m is change or increase in y all over increase or change in what? In s. That is why you will see most of the time we write it as m equal to y2 minus y1 all over s2 minus s1. Whatever we get here will become our gradient. We can also do that in calculus. What are we going to do here is to what? Is to derivate. That's where we are going. Is to derivate the any function we are given, and we be given the value of s to put in. Let us take one question as an example. Let us look at this. The questions goes like this. Find the gradient gradient function of y equal to s squared plus 3s plus 1. Look at this question now. Find the gradient function of y equal to, and we are not given any value for s. What are we going to do is to, the y equal to s squared plus what? 3s plus 1. Sometimes you may be given s to be like 1 or 2 or anything, but we are not given anything. We are going to derivate this. That will be the y ds. The y ds means when you are asked to derivate, even we are still going to treat it in the differentiation from the first principle. What are we going to do when you are given 4s cube? This is y. The y ds will be 3 times 4. That is 12. That will be 12s. This will be 3 minus 1. This is 12s raised to power what? 2. Here, this will be 2 times, there is a coefficient here. As you know, here we have coefficient, abi? Coefficient of this s cube is 4. Here, the coefficient of this s is what? 1. This will be 2 times 1, 2. That will be 2s, 2 minus 1, plus here, the coefficient here, we have 1 at the top. 1 times 3, 3. S raised to power 1 minus 1. Now, the y ds of this one is what? Is 0. Therefore, we are having 2s, that is one we don't need, plus what? 3. This is 1 minus 1 is 0. Anything raised to power 0 is 1. That's 1 times 3, 3. Now, this is 0. Now, look at what we are having. The YDS is 2s plus 3. And we are asked to find the value of s. We are going to equate this to 0. This is the 2s plus 3 equal to 0. 2s equal to minus 3. That's 0 minus 3. S equal to minus 3 minus 3 divided by 2. Therefore, the value of s is minus 1 whole number 1 all over 3. 1 over 2, sorry. 1 over 2. That's 2 times 1, 2 plus 1, 3 all over 2. Let us check another question on gradients. The second question asks us to find the gradient Now, let us look at this question. The question says, find the gradient of the tangent to the curve y equal to 2s squared plus 5s minus 3 at point where s is. Therefore, the gradient now, which is m, equal to the y ds. The y ds of this now is 2 times 2, that's 4s, plus this will be 1 times 5, 5. 0. This will give us what? 5. We have got the what? The, the gradient is 4s plus what? 5. We are told that at the point where what? S equal to, not the here, where s is what? Is equal to 0 here. Now, anywhere we see s, we are going to put what? 1. This will be 4 times 1 plus what? 5. That is 4 plus 5, which is what? 9. The gradient is 9. Let me give you some questions as a classwork. I will be there in the comment section to to see your workings. Now look at the class work on gradient. 3s 3s raised to power 4 minus 2s cubed plus 4s squared minus 1 at s equal to minus 1. Find the gradient at s equal to 2. Why is this? Now we have finished workings on gradients. We are going to start on differentiation from the first principle. Please, before we start, help me to subscribe to my YouTube channel, like and comment. Thank you very much.